Hi, today we will discuss the importance of modeling and designing methodologies when creating a new system. We will start by discussing structured methodologies, followed by looking at object-oriented development, and we will wrap it up by looking at some software tools that can enhance the use of these methodologies by a development team. When it comes to designing and modeling systems, there are several methodologies that can be employed to help defining a system's architecture and allow more efficient development in later stages of the system's creation process. Different methodologies can focus on different aspects of the system architecture and can usually complement each other. In these slides, we will discuss two of the most commonly used types of methodologies, starting by the structured methodologies, which has its focus on process modeling, followed by object-oriented methodologies, which also looks at data as a key component of a system. Looking at structured methodologies, these usually follow a step-by-step approach, where a step works on top of the result of the previous one. But they can also employ a top-down approach, with the aim of presenting a more general perspective of the system, followed by a more detailed perspective of its subcomponents. As previously stated, these methodologies focus on process representation, with data playing a secondary role. We can implement these methodologies by using data flow diagrams, as shown in Figure 1, which allows to model a system as a set of processes, represented by round boxes, by which data flows, which is represented by the arrows. Other participants can also be represented, such as data storage or external participating entities, which can be pictured as open rectangles and square boxes, respectively. Now, considering the top-down approach, we can look at processes as an aggregation of subcomponents. Furthermore, it is also common to find processes with similar purposes inside the system. To model these observations, we can use structure charts, which allows to present a system-wide perspective with different levels of granularity, as shown in the picture below. In this picture, a system with the intent of processing payrolls can be seen as a composition of three processes, each of them composed by two sub-processes. Although structured methodologies allow to present a detailed model of the system's processes, it does not offer good representation of data and its relevance in the system. Object-oriented methodologies introduce a way of modeling systems based on basic units called objects, which are composed by data and by the processes needed to work on it. This data becomes only accessible inside the object it belongs to. By including messages that allow objects to communicate between themselves, the focus is shifted away from processes, and we try to present a system as a composition of objects working together to achieve a certain goal. Another positive aspect of object-oriented methodologies is that we can look at objects with similar functions and try to aggregate them in classes. Classes aggregate the similar characteristics that can be found in several objects, with the intent of minimizing the number of times these aspects are represented in the system. Looking at a practical example, we can consider salaried, hourly, and temporary as different objects that represent employees. We can then represent their shared characteristics in a single class, named employee, and we can propagate them to objects using inheritance. Besides simplifying the system's model, this approach can also be applied to development stages of the system, allowing to find regions of the system where code can be reused for similar components. Although employing these methodologies can be time-consuming, the benefits in later development stages heavily outweighs the impact of these methodologies in earlier stages. In order to reduce this impact, several software tools were created with the intent of enforcing some standardization to facilitate the coordination between teams, while also allowing the inclusion of some degree of automation. A good example of one of these tools is Microsoft Visio, which allows the creation of diagrams, as shown in the picture. To finish things up, we can look at a simple application of one of these methodologies applied to the Google search engine. As we can see in the picture, by using a data flow diagram, it is possible to picture a simplification of the pipeline used by Google to present results to our searches on the web. And that is all. Hope you have enjoyed, and thanks for watching.